Eighth grade science. Today we are finally back to a video. I know we've been doing a lot of reading during the introduction to new material, but today is best for a video. So what we are going to work on is counting formulas again, looking at a formula of a compound and determining how many atoms of each type there are. But today we're going to talk about linear formulas and formulas with parentheses. So it's a little bit tougher than what we worked on before. So let's start up top. We're working on linear formulas to begin. This is page 1 of your packet. And up top it says sometimes compounds will be listed out in linear form when elements of the same type aren't combined. When this happens, be sure to add up all the elements of each type. So in a linear formula, we can look at this example right here, NH4NO3. We can see that nitrogen shows up twice. Sometimes scientists do this to make sure that people understand what the formula actually looks like in real life. They list it out in a linear form. It's not that much tougher for us in 8th grade science. So all we'll have to do is look at how many nitrogens there are in the atom or in the molecule, the whole molecule, and add them up. So let's start with actually hydrogen because that's easier. If we look at the H, we see it right here. There is a 4 next to the H, so we can go ahead and say that we have 4 atoms of hydrogen. All right, that one's pretty simple. Oxygen's the same. If we look towards the end, we see a capital O. There is a 3 next to it, so that tells us there are 3 atoms of oxygen. But now this is where it gets a little bit different from what we did before. Before, we would always say that if there's nothing hidden or if there's nothing written by the N, it's a 1, so that's true. So right over here on the left side, we have 1 N. But look at this. If we keep moving to the right, we see that we have a second nitrogen, all right? So the answer here is that we actually have 2 atoms of nitrogen, not just 1. And then if y'all are interested in seeing a picture or a model, here's what NH4NO3 actually looks like. Here's your NH4. I'm circling it right now, your nitrogen with 4 hydrogens. And here's your NO3, the second part of the formula, your nitrogen with 3 oxygens. All right. You'll talk more about that when you get to high school chemistry, but for now, it's good to know. All right, so linear form, there's going to have written out in a row, and you need to be able to figure out how many there are of each type. They won't always be counted, okay? So let's look at our second example, another linear formula. It's CH3CH2Br. All right, so let's start with what's easy. I see that there's only one Br, and I used red, so I'm going to actually use colors here. Y'all don't have to use colors. But I saw that there was 1 bromine, right? There's a single Br at the end, so I'm going to say 1 atom of bromine. If we look at our model, you won't always be given the models, but red is the bromine. We have 1, all right? Now let's try and do our carbons, because there's going to only be 2 carbons, as we'll see. But we read here, we go left to right. Here's a carbon. There's no subscript, so that just counts for 1. Keep moving my mouse. These are hydrogens. Keep moving my mouse. Okay, here's another carbon, so that's 2. Keep moving my mouse. That's all we have, all right? So that means we have 2 atoms of carbon, all right? Then to finish up here, y'all, we are going to count our hydrogens. I'll switch to gray because that's our color in the model. We have our 2 carbons, which were black, and now we look for our hydrogens. Start from left to right. Carbon, that's not it. Here's hydrogen with a 3, so I have 3 hydrogens, but I know I've got more. Keep moving, don't count that C. Here's 2 more hydrogens. 3 plus 2, y'all, gives me 5 atoms of hydrogen. All right. Then if we check our model, we should find 5 gray spheres. 1, 2, 3, 4, 5. It all lines up. All right. The tricky part on linear formulas is not forgetting to count all of the atoms. Do not forget to add them up as you go. All right. We're going to do a little bit of those, but our bigger focus, y'all, if you scroll down, will be on formulas with parentheses. And here we're talking about groups, okay? Talking about groups of things. So up top it says some formulas have parentheses. When a compound has elements in parentheses, the subscript applies to everything inside the parentheses. So let's explore this and see how it looks, all right? This formula we just start with is AlNO3, 3. Aluminum is out in front of the parentheses. Nitrogen and oxygen are inside the parentheses. So let's start with aluminum, all right? You can see in the model, y'all, aluminum is gray. So I'll give myself gray for aluminum. And it is outside the parentheses, Al right here by itself. there is no subscript, so that tells me, y'all, I have 1 atom of aluminum, all right? If we wanted to double check ourselves, we can look at our model. I said aluminum is gray, and there is 1 gray sphere, all right? Don't go just off of the model because you won't always have those. This is just to help you out as we're first learning this concept, all right? So the Al is taken care of, but now I have to go inside the parentheses. See, I got a parenthesis right here and a parenthesis right here. Inside of there, I have NO3. So every time you use parentheses, this little subscript outside of the parentheses, the 3, applies to everything inside the parentheses. So this is basically telling us I have 3 groups of NO3, all right? So I know that there's nothing written next to the nitrogen. That means that normally we would just have 1 element or 1 atom of nitrogen, but now there's a parentheses and there's a 3 on the outside. So when I would normally have 1 atom of nitrogen, now I got to multiply that by 3. 1 times 3, y'all, gives me 3 atoms of nitrogen. And if I want to double check my model, nitrogen is blue. Here's 1 sphere, 2 spheres, 3 spheres, all right? Remember, you take what's inside the parentheses and multiply it by what's outside of the parentheses, okay? Let's do one more. Let's do oxygen. This is red. Normally, if I'm just looking inside the parentheses, I have 3 oxygens because there's an O3, but I got to multiply by what's outside the parentheses, all right? I have 3 groups of 3 oxygens. That gives me 9 atoms of oxygen. If I check my model, I should find 9 red dots. 1, 2, 3. That's 1 group. 4, 5, 6. That's the second group. 7, 8, 9. That's the third group, all right? Always have to multiply what's inside the parentheses by what's outside the parentheses. Let's try one more. And then right here we have CO, NO3, 2, all right? And we know that CO is 1 element, not 2 elements, because it's got an uppercase and a lowercase. So this is actually cobalt, all right? Let's start with cobalt. It's outside the parentheses. Because it's outside the parentheses, I don't multiply by anything, and there's a hidden 1 next to the CO. So that tells me I have 1 atom of cobalt in this example, all right? Now let's move on up. Let's get into blue and our nitrogens, and we're going inside the parentheses, so let's get ready. Inside the parentheses, I have NO3 and then a 2 on the outside of the parentheses. That means there are 2 groups of NO3. So I look at nitrogen. It's inside the parentheses. It has a hidden 1 as its subscript, and I have to multiply that by what's outside the parentheses, which is 2. So I have 1 nitrogen per group, 2 groups of nitrogen. That gives me 2 atoms of nitrogen. If we check our model, we should have 2 blue spheres. We have 1 sphere and 2 spheres, all right? Last example is oxygen, y'all. Go inside the parentheses. In a single group of this molecule, we have 3 oxygens. I have a little 2 outside my parentheses, which tells me I have 2 groups. 3 groups of 2 oxygens, 3 times 2, gives me 6 atoms of oxygen. I come up and I check my model. I should have 6 red spheres. 1, 2, 3. That's my first group. 4, 5, 6. All right, y'all. So this is pretty heavy on math, but if y'all are thinking the right way, excuse me, I have to cough. If y'all are thinking about this as groups and multiplying, you will be all right, remember? Linear formulas, you just got to add them up. Just count left to right. Do not forget to add all atoms of the same element. When we get to the bottom with parentheses, it gets a little harder. You have to make sure to multiply everything inside the parentheses by the subscript outside the parentheses, all right? This will be pretty confusing, but if we're working together on this guided practice when it's next, we will be all right, okay? So if y'all are finishing before the timer, you can go check out this guided practice. Otherwise, make sure you understand these few examples we just went through. We're working on guided practice next. Great job, y'all.